Hello, everybody. My name is Ron from IDC Consortium, and welcome today. Welcome I'm one of the project member partners of the CHIC project, and welcome to the Future of Tomorrow CRISPR and Gene Editing Roundtable discussion with influential youths of today's global society webinar. We are excited to host this event and looking forward to a very lively discussion. We encourage everyone's participation, so please feel free to send us your questions via tweet, which is already in the comment section, and also send via comment or raise your hand. And without further ado, here's our moderator, Erik Toussaint.
Oui, merci. Hello, everybody. My name is indeed Erik Toussaint. I'm communication advisor at KeyGene in Wageningen. That's a research company, a plant research company in Wageningen. And we are one of the research partners within the CHIC program. I'm a communication advisor and I'm passionate about plant breeding and to tell about plant breeding. So that's why I'm here. I will be your host tonight, together with Ronald, you just met. Ronald will help us to do all the techniques. And so we will not see him from here, but he will be in the background. Together with Ron, we will select questions from the audience to be answered or remarks to be discussed. So indeed, please mention your questions and remarks in the chats or through Twitter. I just put our Twitter account in the chat. It's at h2020_chic, and Ron and I will together help you to get the questions answered. So let's start by giving the floor to our guests for tonight. We have 6 persons, 6 young influentials. And let's start with the people from Umbra. Rosanna, can I please invite you to take the floor and introduce yourself?
Hello, I'm Rosanna. I work at the Edinburgh Centre for Carbon Innovation at the University of Edinburgh. Yeah, I'm really pleased to be here this evening.
Oh, very much welcome. Sonia, can I give the floor to you?
Hi, thank you, Erik. I'm Sonia, and I work in education for sustainable development in the higher and further education sector in the UK, and also in the utility sector. And I am looking forward to having this discussion and learning more.
Okay, and you're located in the UK, right?
I'm located in the UK, yeah.
And Rosanna, where are you now?
I'm in Glasgow, and so is Sonia.
Yeah, we're
okay. You're both in Glasgow. Okay.
Yes.
Fiona, go ahead, please.
Hello, I'm Fiona. I am today in Brussels, where I work for the European Parliament for the Youth Outreach Unit. Yeah, very much looking forward to having this discussion today.
Well, we are glad to have the Umbra Collective with us. And we are also glad that we have the GeneSprout Initiative with us. 3 people from the GeneSprout. Ramon, you popped up first. Go ahead, please.
Yeah, so I'm Ramon de Koning. I'm a PhD student here at the Free University of Brussels, where I do research in the plant genetics lab of Geert. And I'm doing research on the common bean, which you can here see like some pulses of. And I try to enhance the nutritional quality of the bean using CRISPR, so one of the new breeding technologies. And I'm also very happy to be here, and yeah, I'm curious.
Okay, thank you, Ramon. Nikita, go ahead, please.
Yeah, thank you, Erik. My name is Nikita, and I am a PhD student at Wageningen University in the Netherlands. And my research is about improving germination of seeds for breeders and seed companies, but also for farmers in the end. And yeah, I'm one of the co-founders of the GeneSprout Initiative, which, yeah, we love to take part in science communication. So we're really happy to be here as well.
Thank you, Nikita. Juriaan, you're next.
Yeah, I'm last. I'm Juriaan Rienstra. I'm a PhD candidate here at Wageningen University in the Department of Biochemistry, where I try to make very specific changes to certain genes in the plants. And we hope to one day translate this research to crop plants using CRISPR-Cas.
Okay, thank you, Juriaan. So next to these young influentials, we also have 2 experts from the CHIC research consortium. Armin and Katja. Armin, can I give you the floor first?
Thanks, Erik. My name is Ahmed Shberg. I'm a science and society researcher with Graz University of Technology, based in Austria. And as such, I'm partnering with the Chicory project, CHIC, particularly interested in exploring the views of stakeholders on the type of chicory we're developing.
Thank you, Armin. And last but not least, Katja in Wageningen.
Hey. I'm also in Wageningen right now here in the plant research building. And I am a CHIC researcher, so I'm a plant scientist. And I'm mostly interested in plants that make a variety of very interesting compounds that are interesting for our diet or as medicines. And in the CHIC project, I am actually doing the CRISPR-Cas gene editing to improve chicory to have better dietary terpenes, dietary fibers and terpenes.
Okay, thank you, Katja. And perhaps we can ask you to explain what this is really about, because I can imagine that not all of our audience knows what is gene editing of a chicory plant. Many may not even know what a chicory plant is and what it looks like. So could you perhaps explain what this work is about, this gene editing of chicory? How does it work? How much time does it take? Where do you need to go in the lab, whatever?
Mm-hmm. Well, chicory is really a small crop that is grown in the north of the Netherlands. I think you know this plant because it's flowering all over Europe in the summer. That has a typical blue flowers. And many of you have tasted chicory. Maybe you call it differently. Maybe you call it radicchio or you call it witlof in Belgium. So this is a typical lettuce type crop that people are eating and appreciating for their bitter taste. But the chicory that we work with is a bit different. So normally we work with root chicory varieties, and they have enormous roots up to 70 centimeters long. And these roots are very interesting because they are very much filled with fructose polymers, and these are excellent dietary fibers. And this root chicory is grown in the north of Europe, mostly in Belgium, the Netherlands, and in the north of France. And that's actually the crop that we are talking about today.
Okay, and how does it work? You take a plant from the field, or how do you work with it?
Now, actually, it works a bit different. So you see that we have here chicory grown in vitro. That means that we give it nutrients in a sort of agar. It has all the vitamins that it needs for growth, but also sugar. So this one makes very tiny roots that you can see here because it doesn't need to do a big effort to eat because we are feeding sugar to it. But the way that we do gene editing in these plants is that we take a tiny piece of the leaf and we isolate single cells from them. And we introduce a little protein in there called Cas9, and that protein can make changes in the DNA. And what is so nice about gene editing is that we can direct those changing by also adding a guide RNA. And actually then the protein is guided to a specific place in the genome and only a few letters in the DNA of the plant are changed. And what happens next is that you see, this is the next stage in the procedure. You see that there are clumps of cells growing here, and these cells are regenerated from that single cell. And you see that they start forming tiny plants. So let's say from having a plant here to having new plants that have a few letters in the DNA changed, this procedure takes about 3 months. And we still need to grow these plants, and that will take another 2 months before we can really look at them. And in the next stage, we look at the genetic makeup. So do we really have a change in that DNA? But for us, it's even more easy because we can look at the products of the DNA. So we are looking whether the dietary fibers and the terpenes also have been changed. So this is what is going to happen with these plants in about 2 months.
Okay, so you will analyze it then.
Yeah.
Okay. Thank you, Katja. So I would like to ask our audience to join us in a poll. And for that, you can go to menti.com and use the code 347899. And we will have 7 questions for tonight. And they are all of them are, say, propositions, and you can disagree or agree with it. So please go to menti.com and then 347899. Hang on. There you are. So the first question to all of you is, do you like the idea that gene editing will help to make agriculture more sustainable? If you agree, you say, yes, I agree. If you don't agree, I totally disagree. Do come in with all your comments. By the way, the idea is that at the end of this roundtable, I will try to make a PDF from all our results, and we will share that in the chat. So everybody can take it home if you like, right? So we got over 60 participants. Let's give it another sec. Okay. Well, it seems that our audience is pretty positive about the idea that gene editing could help to make agriculture more sustainable. Well, we can think a lot of this. Maybe Armin, you could reflect on this.
Well, it's a bit surprising for me. That picture that's emerging. I'm based in a country which is very reluctant to has been very reluctant to adopt genetically modified crops. So I'm used to a different pattern.
Oh, yeah.
And that pattern that has been emerging here actually is very few people show this kind of reluctance or even outright rejection.
Yeah.
So from that, we can draw some interesting questions, actually. The question is, it seems that genome edited plants do make a difference. That's compared to genetically modified crops that we had since 3 decades now. They were having since 3 decades. That's one question that you can derive from. When the other is that our audience is very much composed of natural scientists in favor of that. Okay. But I don't think so. If there is something I would rather say that there seems to be a difference between genome edited and conventional genetically modified crops.
Okay, thank you. Okay, well, let's get to the propositions that our members of the roundtable have sent to us as an inspiration to talk together and to ask questions to one another. And let's start with the first proposition. It's by Rosanna. I'm concerned that companies holding patents on gene editing techniques will use that power in an irresponsible way. So Rosanna, can you please explain about this proposition?
Yeah, sure. Sorry, I'm just finding what I wrote down. So when I wrote this proposition, I was thinking about the fact that in the past, companies like Monsanto have abused their power in countries like India with seed patents and things like that, and put farmers in dangerous cycles of debt, and they've controlled crop production.
Okay. And you're afraid that this may also happen to the gene edited crop?
Yes, I mean, I'm not sort of saying that it would immediately go to the worst case scenario like there was in India, but I think that it's something that should be approached with caution.
Okay, let's go to the Mentimeter. Hang on, I need to do a lot of things. There you are. So Rosanna says, I'm concerned that companies holding patents on genome editing techniques will use that the power in an irresponsible way. Go ahead, please. Okay. Well, that's nice. This gives a sign that people are differentiating in their opinion here. And of course, I'm also curious about when we are concerned about something like this. Rosanna, did you also give it a thought of how one could avoid that this could happen?
I guess that's quite a big question. I think tighter regulation or legislation on this, and I think really the problem with a company like Monsanto is it's so powerful that it's kind of hard to regulate that kind of company. And yeah, I mean, it kind of depends how large the company is and how influential it is.
Yeah, and Armin, you talk a lot with our stakeholders in our project, right? Is that something that you also hear in our stakeholders, that they are worried, and do they also talk about possible solutions there?
Well, I have to say that in the course of the CHIC project, so the intellectual property rights issue did not come up so far. But in the more general discussion about genome editing, it's a very relevant issue. So, and the main question is, would genome edited plants make a difference in terms of patent rights?
Yeah.
And some people are actually thinking that this might be the case because besides Monsanto, there will be many more smaller companies that will be active with genome edited crops. So it's not no longer to a few multinational being in control of biotech crops any longer. And another issue is that the patent challenges have not yet been resolved with genome edited crops. For example, if you change just one base pair, one letter in the genomic code by genome editing, how would you be able to differentiate whether a plant with this change has resulted from genome editing or from natural mutation? You would not be able. Therefore, it's an unresolved questions how a patent claim and the patent dispute would then be solved.
Yeah, it would be difficult indeed.
So
there is a question now from an anonymous attendee. How could a single letter change in the DNA have a huge impact on terpenes or dietary fibers of a plant? Do you introduce many mutations? What is the expectation? Perhaps Katja could answer this. So how could it work that only one DNA brick can have a huge effect on the terpene production?
Well, we know very well how the plants make the terpenes and how they make the dietary fibers, so the inulins, and there are several enzymes involved in this. So in the biosynthesis or in the degradation of this compound. If I give you the dietary fibers as an example, we know that the plants are making them through the whole season, all the way to the, let's say, October or November. And when the first frost starts, the degrading enzymes get activated to help the plant that is not synthesizing a lot of sugars anymore at that time. And for example, if you understand this process, you can interrupt only this degrading enzyme, and that is then enough with one change in the DNA to stop this degrading enzyme to work. And that's how you keep more of your dietary fibers in the plant.
And how does it work then when you alter one DNA brick, right? How can it be that an enzyme gets totally inactive?
Well, there are two mechanisms. Normally, when you change one letter in the DNA, that could mean that only one amino acid in the enzyme would change and then the enzyme would still work. But if you have a deletion of a single letter of the DNA, the reading of the words, let's say that the DNA encodes, gets completely scrambled and those proteins cannot work anymore. So even though you introduce a small change, the enzyme that is there cannot work anymore. And if you understand the process, you can interrupt the process at a certain point.
Okay, thank you. This was not about Rosanna's proposition,
no.
But it was a relevant question, I think.
Yeah.
So thank you for answering that. Yeah. So would anybody get back on this proposition that, yeah, okay, Ramon, go ahead, please.
I was actually wanting to say is, actually, if you look at Argentina, and it's actually a country in which they already regulated NPBTs, so the new plant breeding techniques, and that they already did for 4 years. You have like a very special thing going on, as in like if you look at the traditional GMOs produced, you can see that 90% of those GMOs are owned by big multinationals.
Yeah.
But if you look at plants created with these new plant breeding technologies, you see that actually the majority of those plants are actually created by local companies, public research institutes, or small and SMEs, like small and mid-cap enterprises. So basically, the biggest part, let's say 80%, is produced by small companies, and like only 9% is produced by big companies. So big.
How do you think that it is happening this way? So much different from GMOs or normal GMOs, let's say.
Well, because with normal GMOs, there is a very large regulation. So companies need to pay also a lot of money for all the studies they have to go through. I think it's around like 10 or 20 million euros they have to pay. Whereas with these new plant breeding technologies, it's much cheaper, it's way faster. And so it's actually much better for small companies to create plants with it than traditional GMOs, I would say.
And am I right that this difference is not so much in Europe?
In Europe, it's different. The regulations there are less clear. Let's state that there has been a court ruling in 2018 which stated that new plant breeding technologies fall under the directive of the GMO legislation. But that also means, if you look more closely to it, that plants created with this new breeding technologies can fall under the category GMO or under the category not GMO. Yeah. As in, if you have a small change, which can also occur through traditional breeding, then they say like the product created is nothing different than the traditional breeding way. So in that case, that product, so that plant, would be regulated as a non-GMO. But if you introduce a foreign gene that's not present in the plant itself, the plant species, then you create a GMO with it.
Okay. Well, this raised a question from Fabio. Fabio, I think we will answer your question later on, because there is also a proposition about plants around our crops. And then it may also be of interest to be able to trace an occurrence of gene editing. So let's make time for the next proposition. It's about Ramon. And it also has to do with farmers. And he is focusing on a specific group of farmers. He says organic farmers should have the option to grow gene-edited crops that are disease resistant and better suited to difficult environmental conditions. Ramon, can you please explain how you came to this proposition?
Yeah, so basically, we all want a world where everyone has enough to eat, and we all want to achieve this in a way without further destroying our planet. And I think these new plant breeding technologies can especially help organic farmers to obtain a more ecological and sustainable agriculture. So we can reduce pesticide usage by making plants resistant to certain pests. We can make plants better adaptable to drought and other stresses. We can lower the inputs needed by making plants more efficient in taking up nutrients. And we can also make crops more nutritious. All these things are really beneficial for every farmer and consumer. And of course, some of these traits can be produced by traditional breeding techniques, but I think organic farmers should also have the option of growing crops in a faster and more efficient way through these new plant breeding technologies, especially now in challenging times with like climate change and the growing population to feed.
Okay, and when organic farmers would not be allowed to use those plants, they will have a delay then?
Yeah, so basically, I would say like if they reject the plants created with these new plant breeding technologies, they miss a huge opportunity, whereas like we all want a sustainable agriculture and we all want to use less pesticides, less inputs in the soil and so on. And I think like with these technologies, it can actually like been achieved in a much better way and in a much faster way.
Okay, thank you. So let's go to your proposition. Let's see whether I can magic. Yes. So here's the proposition of Ramon. Organic farmers should have the option to grow gene-edited crops that are disease-resistant and are better suited to difficult environmental conditions. So perhaps one of our people at the round table can already raise a hand where you would like to ask Ramon a question or bring in a special subject or remark regarding this.
I'd like to say something.
Okay, go ahead.
I think the key in this proposition here is should have the option.
Yeah.
So I guess a concern from like a sustainability and like a social sustainability point of view would be that perhaps with what we've seen from GMOs is that farmers no longer, it's not really an option. They're sort of forced into the market, whether or not they want to use those kinds of seeds. So I guess here it's like, I think they should have the option, but I guess there's a fear that if a type of seed becomes more popular than another seed, that they no longer have that option.
Okay. Other remarks, questions? I do have a question here because Ramon, you could think you're a guy from gene editing. So here's somebody from gene editing saying that farmers in the organic world should be allowed to use gene edited crops, and that may feel a bit like somebody is advising his or her product. And that maybe organic farmers, they choose to be organic for a reason. And there is a drive to bring them to organic farming. It has to do with income, but it also has to do with the concept. So could it be that, that when we say, get to the same subject from a slightly different direction, say, it would be a good idea that we consider gene-edited plants as part of the organic products that are allowed to be sold as organic products, then the farmers can choose themselves whether they are not interested to grow the crop. And we are not saying, hey, farmer, you're allowed to grow the crop. What do you think, Ramon?
I think that would be great. I mean, as long as the farmer can choose which product or which plant he can grow, and like, in his perspective, which plant would be most beneficial for one, his wallet, and on the other side, the planet itself. I think that would be great. And I mean, if we can achieve certain traits like disease resistance through traditional breeding technologies, and such a plant is created, why not use that? That would be nice. But if the farmer also has like the option of like a plant created with these new technologies in a faster way, and he can choose from that one as well, why not? I mean,
okay,
I'm quite liberal in that sense.
Yeah, Nikita, go ahead.
Just to add in a bit, I think when we had discussions with people who were specialized in organic farming, we usually got the reply when we said that would it be nice to have genome edited plants also in organic agriculture, because it helps both organic agriculture in a way to sustain plants in a more sustainable way, but also the planet. And it's mostly the principle of organic agriculture that you don't want to play with the principle of organic agriculture where we do not use certain things and we just will not use it because the procedure is what we believe in and not the end product. And yeah, that is always an ongoing debate because sometimes the end product is more important if it's good for the planet than your principles in the way. But that is going to be a hard discussion to sort of, because I really think there's a lot of benefits for organic agriculture, but also for us from organic agriculture. So yeah, it would be great if it could go together.
Okay, Armin, go ahead.
Yeah, thank you. Just to continue on this issue is I'm based in a country with a very high percentage of organic farmers. So
Yeah.
we have about 20% of all arable land is organic farming in Austria. So organic farming is really important. And also the views of organic farmers are really being listened to. And I have to say that I was really surprised what emerged with genome editing, because in the initial debate in the German-speaking environment, we had a couple of organic farmer representatives, cheers, that were kind of interested in that technology. So they were, they did not really outright reject that. So they said, okay, that could be an option in certain cases with certain traits, but these few, they were silenced quite quickly. By a kind of, they were kind of streamlined by a dominant dominant group in the organic farming community that really decided to stick to the principle, as Nikita mentioned before. So it's a bit, I would consider that as that sticking to the principle in that case, kind of hampering sustainable development in a certain sense.
Okay, but yeah, principles. Yeah, it's difficult, right? These principles, they are gut feeling and they are written down, and then when we want to change, or when an organic farmer would like to contribute to a change in that regulations, that is very complex for an individual organic farmer. So, do you think there would be organic farmers who would be willing to go to the office that determines the principles of organic farming and say, I would like to discuss the possibility to include genetic edited plants as part of our principles, which could be good for organic farming? So would they dare, you could say, would they have enough power and maybe guts to do that?
Yeah, there were certain cases where organic farmers and representatives of that community did that, but they were there. So as a result, with one particular prominent case from Switzerland, a shitstorm emerged afterwards. Yeah. So I think so they quickly silenced this person. Yeah. And I'm aware of less prominent organic farmers, which also would be interested, but they don't dare to speak in public. Yeah, because the umbrella organization of the organic farming community has already decided and put into a document that they will go ahead without these type of plants. So it's already done. I mean, from a business point, probably it's not just a matter of principle, it's also an issue of business prospects, because maybe the organic farming community, at least parts of them, think that it is too difficult for their consumers to distinguish between slightly genetically modified and non-modified, and a third category, really modified crops. So it's perhaps trying to clearly distinguish two worlds, so to say.
Yeah. Yeah, and well, I've been in discussions about genetic modification already for a long time, and I once had an introduction by somebody who was saying, and gene editing is not genetic modification, but you could clearly feel that in the audience, it did feel like genetic modification. So I think we also need to take that into account. And so for consumers, it will be pretty difficult indeed to distinguish between the different levels of, I could say, levels of genetic modification, because it's not just ratio, right? It's also the world we are in. Ramon?
Yes, but in a scientific view, traditional breeding technologies are also genetic modified products. I mean, we already been going on for 10,000s of years with selecting certain crops, whereas a lot of changes happened, a lot of mutations happened, and in a very chaotic way in that sense. And in my view, that's also genetic engineering and genetic modification. So it's sometimes hard to make a distinguishment between those. And I think in a way they are the same.
Yeah, you could say that in a way they are the same. There are even reports that say that the products of genetic modification are not more risky than products of breeding. So that makes it also difficult. So, but for people in the street, for our audience, for me, whether I eat a tomato that's genetically modified or not, it's not just ratio, right? It's how it feels. So we can say scientifically speaking, the traditionally bred tomato is also a kind of genetically modified plant, but it feels different to me, and it may feel also different to others, right? Somebody would like to respond? Yeah, Armin?
I think with food, we have to admit that with food, it's a different story. So we are used that our cell phone will be replaced every year by a new model, yeah? But we are not used to that pace of innovation in the food area. So in the food area, consumers tend to be very conservative, and is also closely linked to kind of cultural, so regional, national cultures in preparation and consuming foods. So I think it's a much more complicated area compared to other areas of technological innovation. And so with food, it's not just the product that matters, it's also the process and who actually is in control of the process, because trust is a big issue here.
Yeah. Okay, thank you. Yeah. So this cultural thing you brought up here, when farmers are doing business, they are also depending on the culture around them, and they also use their own culture. And Sonia is born in Canada, right? Sonia, you're born in Canada?
I was born in Canada, but I'm Canadian.
Yeah. Okay. So, and you brought in your proposition that has a link with culture, right? And you're worried about the impacts of gene editing on indigenous seed sovereignty and local cultures. Could you explain to us why?
Yeah,
why you're worried?
I think that seeds are really tied, well, in the same way that food is very tied to culture, I think seeds are very tied to culture. They are historical and they hold a lot of meaning. So I guess coming as someone who doesn't know, I don't have a science background. So I guess when I hear genetically or gene editing, I'm worried that will that change the way that a culture saves seeds, shares seeds, tells stories about seeds, uses food. How will that impact their sovereignty to decide how they want to live their lives, essentially, and how will that dictate their culture? And so I know we're talking about specifically, like, I think, so there's chicory, and I know that it's not, there's no indigenous populations in the Netherlands, so it's not specifically relevant. But I think the bigger picture of changing something and having, yeah, I'm just worried about how that can have an impact.
Okay. So let's get to your proposition and see what our audience thinks of that. Indeed, gene editing, well, we should take into account that it should not have a negative impact on seed sovereignty and cultures, local cultures of farmers and also the people around them. So in the meantime, there came a question. Hang on. So Peter, I think we will try to deal with your question at the end, right? I would like to go on with the proposition of Sonia. Okay. Thank you, Peter. Okay. So, Sonia, did you give it a thought of how we could avoid this? So gene editing could have an impact on local culture and how people deal with seeds and how farmers will deal with seeds.
I think it goes back to allowing cultures and farmers and communities to have a choice. And so I brought this up earlier. I think that say the climate crisis advances to a point where we need this technology, I think so many cultures will no longer have the choice not to use that technology. And I think that's bad. So I think we can preserve cultures and preserve ways of living by literally just giving people many different options of how to use seeds.
Okay, so you're especially worried about the fact that cultures may be forced to use the technology, not they are forced to use the product, but because when you think of, for instance, when you have a specific crop for a specific region, right? And farmers are sharing the seeds over there. And there is a new disease coming to that area, coming from another area. And with gene editing, one may be able to alter this local variety or landrace or whatever with a relatively simple step, changing the trait of this local variety with only one slight difference, but would not make the plant, this local variety, resistant to the new disease. But am I right that is not something it's more that you're worried about the use of the technology, that they are forced to use the technology?
Yeah, and I also think what you just mentioned is like best case scenario. And I do think
yeah, sure, yeah.
Yeah, I guess I'm just thinking of like BT cotton in India and how farmers were basically forced to use BT cotton and how that really affected their livelihoods. And I really just want to emphasize like giving farmers and communities the option to not use gene edited seeds and technology. I might not be using the right terminology because I don't have background knowledge.
Perfect, I think.
Yeah.
Okay. Well, who else could I give the floor to share thoughts about this the free? Yeah, Jurian, go ahead.
Yeah, I'm not sure if I can fully answer your question, but the way that I can see how we could use CRISPR is that in Peru, for instance, they grow a lot of quinoa. But it's not the crop that has the highest yield. So, and of course, the seeds are also toxic. You first have to clean the seeds before you can actually eat it. So I can see a future where either these farmers will have to go to a conventional crop, or what we find conventional, like grow a wheat variety that has been bred to grow at high altitude or something, or we use CRISPR or gene editing to change the quinoa plant to improve its yield. And another use case that I can see is that we have a lot of varieties of potato all over the world, but also of rice, also of tomato. But to just give an example of tomato, tomato was domesticated primarily by changes in 5 different genes. And it was already shown that if we introduce these 5 mutations in a wild variety of tomato, its yield was improved tremendously. So I can see that instead of us having to, move our own tomato variety to everywhere in the world, we can actually locally domesticate these plants to improve the yield and also maintain the species that they're already growing there.
Okay, thank you.
I'd like to say Aramka has just posted a message, and I completely agree with what she said that it's not the technology, but it's the human practices. And so I just want to emphasize that.
Okay. It's the people that matter, right?
It's what people do. It's not.
That's right.
As I mentioned to you, Eric, it's science isn't evil, people are.
Yeah, that's right. It's about a lot of things, right? It's with a lot of things around us. The thing itself, it's not bad. A knife is not bad, but one can do bad things with a knife. And one should be aware of, at least I think, one should be aware of those things to be able to discuss it. So I think it's very good. I would like to ask our audience to use the chat function instead of the Q&A. And that is because the chat function can be seen by everybody. And I'm not sure whether everybody can see the Q&As. And indeed, some of you already placed your question or remark both in the chat and in the questions and answer.
Erik, I think they can see the chat, the Q&A as well.
Yeah.
But that's great if they can put it on
chat. I need to open it every time. So
yeah.
for me as a moderator, it will also be good to.
Okay. Well, yeah.
Yep. Okay. So Aranka, I think it's pretty much clear what you said there. All right. Okay. No, it's already 6:45. So we had a nice talks about our propositions, but I would like to give our audience and our roundtable the opportunity to also discuss the other propositions. And Sonia, thank you for your proposition. And next up is Fiona. And Fiona's statement is that gene editing will cost a lot of money that could be spent on a less costly climate change mitigation strategy. So a strategy that lowers climate change. So why spend money on gene editing? So Fiona, can you explain about that, please?
Yeah, of course. Yeah, so basically I was thinking that even in the best case scenario that like we will figure out that this is actually amazing, an amazing adaptation strategy for climate change, as you as this is kind of framed as something that's supposed to make farming more sustainable and everything. I think it can easily be seen as a tool that like sounds a lot cooler and like a technique that's, let's say, a bit sexier than like just old school methods of like scaling down farming, having like permaculture, having like traditional ways of having lower emissions in agriculture. And I just think we have so many, like the science is so old, we all know how we could like just fight climate change if we really started to do that. So I just kind of think by focusing on things like these new plant breeding techniques, even if they turn out to be an amazing adaptation strategy, I think we kind of put the focus away of actually trying to mitigate climate change in a meaningful way, because obviously these techniques cost a lot of money. So I think, we could probably focus more on trying to avoid that we get to a stage where we need these gene edited plants, because if we don't face the severe weather conditions that we are going to if we don't do anything about climate change, maybe we wouldn't need gene edited plants. That was my thinking.
Okay, well, let's go to your proposition and see the response of our audience. Okay, well, this is the first time I think we have an opposition, Fiona. So would it be a good idea if I ask the audience whether there's somebody in the audience who would like to explain why he or she totally disagrees? Let's see. So Ron, can you help me?
Yes, Erik, just I can see it.
So perhaps there's somebody in the audience who said, I totally disagree with Fiona, and I would like to give the floor to that person to explain why he or she disagrees. I'm not sure whether we will be able to do it, but we'll give it a try. Did somebody raise hands? Ron? Okay. Well, let's give. There you are. Marcelo raised his hand. Ron. We're trying to activate it, Marcelo. Ronald, I'm not able to see Marcelo.
Yeah, I lost the person.
Okay, Marcelo, can you raise your hand again? Sorry, guys, but let's spend half a minute to try to get this fixed. No.
Go ahead.
Yeah, okay. Do you manage? Did you manage?
Marcelo?
Ah, yeah, there you are. Go ahead, Marcelo.
Marcelo, you're still muted.
Yeah, you can. Yeah, there you are.
Okay, can you hear me well?
Yes, I can hear you, Marcelo, and I think the rest can hear you too. Go ahead, please.
Okay, good. Yeah, I disagree with that statement since our mission, those people that work in crops, right, is to feed the population that we are today and the planet that is going to be in 2050. The people talk about 9.5 billion people. So whatever we can do to have a less impact in our planet, including gene editing, could improve yields or boost yields and feed the population. And by consequence, we will help the planet to don't be over-aggressive, implementing other agronomic practices such as more fertilizer, more pesticides, etc., to boost yields. So I think by default, using gene editing to improve yield will help to mitigate climate change.
Okay, but the amount of money involved to do that. Say you want to develop a rice variety which is adapted to drought, and you use gene editing. You need a lot of money to do it. That's the idea. What Fiona says, it costs a lot of money. Why not spend this money to measures that lower the climate change?
Oh, this is my guess. I think because the money you will invest in that effort will pay off by far with the implications to have better crops adapted to drought or dry land.
Yeah.
Versus invest that money in direct practices that could mitigate climate change. I think the impact is broader or larger when you do it in agriculture versus directly in mitigation practices focused only on climate change.
Okay. Thank you, Marcelo. Rosanna, you want to respond?
It's not particularly, it's not like a direct answer to this question, but about the topic and Fiona's proposition. And I think I agree with Fiona, and I've noticed that there's some things coming up in the chat about like high yields and the lack of high yields in countries that need them. And from my experience in studying food systems, that I've learned that there is enough food to feed everyone in the world. It's just distributed completely unevenly. Yeah. And our food system is fundamentally flawed. And I think what's interesting me in this discussion, and it would be good to talk about, is so far we haven't really spoken about the changes that we need to make to our global food system. And this, I think I'm concerned that gene editing and saying that we can produce crops with higher yields, it's not really changing the fact that our food system is unsustainable and inequitable towards farmers in developing countries.
It would distract attention.
Yeah, and I think we could just keep going down a road that's not working anyway, instead of taking a step back and looking at the whole issue.
Okay, thank you, Rosanna. Yeah, Julian.
Yeah, but it's also not that we're saying that gene editing is the only solution. We think that there are multiple solutions. Gene editing is just one of them. I also agree that the conventional agriculture, as we do now, with spraying with so much nitrate and pesticide and stuff, that it's definitely not sustainable for the future. So something has to change. But why can't we use both worlds for that?
Nikita?
Yeah, I also, it's just extending on that point, that we have a huge toolbox, and I feel like sometimes gene editing is sort of looked at, why do we need it till we really need it? Well, why not use it if it can really help now? Because when climate change really hits us bad, then we are suddenly like, oh, let's adapt gene editing, but we need to be prepared for it. And secondly, in conventional agriculture, it's actually more expensive in the end than gene editing because it takes longer. You use so many you use much more land because you need to grow fields and fields and fields of plants to select that 1% that you want to take forward. So every time there's a selection of one plant out of 1,000 plants that have the trait that you want, and then you move further. That's how things are done in conventional breeding and with mutagenesis, the EMS mutagenesis, which is allowed in Europe. While with gene editing, you can do such targeted mutations, you can reduce the input to the soil, you can reduce the amount of water and all the things you need to grow these generations of plants. So in the end, it will also be cheaper, I think.
So in the end, there would less investment be needed.
Yeah, I think also small breeding companies will be able to do it faster. Yeah.
Okay. So yeah, go ahead, please.
Thanks for that, Nikita. I think that's really interesting. I guess in terms of, I completely agree that I don't think it should be like a thing that we completely write off. Definitely agree with that. I just think that perhaps the danger is in, I was telling Rosetta and Fiona about this earlier, but perhaps the danger is in the fact that we might rely on it too much. So for example, with carbon offsetting, like carbon offsetting is definitely a last resort in the carbon hierarchy. It's like avoid, reduce, carbon offset. And so perhaps if we could see gene editing more like that, rather than like the only way forward for food systems, that could be a more sustainable way.
Rosanna, you also had your hand raised?
No, I was just going to say thank you for those responses, but I actually had a question, and I'm sorry if this takes us away from this, but we were actually talking about it this morning, and it's something that I wanted to ask. If you have sort of a monoculture of gene edited crops, is there still natural diversity occurring in that monoculture, or is it not?
More or less compared to the current?
Compared to non-gene edited crops.
Is there a crop specialist among us?
Sorry, if I understand your question correctly, you are asking if monocultures will lead to loss of biodiversity?
Well, especially the new molecules.
Gene-edited monocultures
generated using gene-edited crops. So when you have a monoculture traditionally bred or GMO, or no, let's traditionally bred, and a monoculture gene editing, do we expect any difference in the biodiversity in the crop and around it?
I don't think it's going to be any different than the monocultures that are being done already. So it's not going to make it worse, for sure. Yeah. But it's already a practice going on for a long, long time. So that's an issue in itself. Okay. But I don't think that is related to a new technology like gene editing.
Okay, thank you. Thank you. Well, of course, I'm chair, so I'm not supposed to give my opinion. But I do think that it could be a good idea to keep an open eye that politicians will not say, well, we don't need mitigation because we can deal with climate change, right? We can adapt. And I think Fiona's point is, and I think we almost all agree, that we should keep an open eye on possibilities to mitigate, to reduce the impact on climate change. And politicians have sometimes a short-term horizon. So, and all of us together, people with gray hair and young people, I think it would be very valuable if we make clear to politicians that using genetic modification or using gene editing doesn't mean that we don't need to take action on the field of mitigation. Is that right? I think you all agree, right? then my opinion is not that important, but perhaps it's good to say it, right? Okay. I think Fabio says gene editing can be used to increase crop diversity, as its breeding do not rely much on backcrossing and conventional breeding. Yes, that's true. I think there have been examples of that. You could even say theoretically, you can increase genetic diversity. You can create new biodiversity using gene editing, but you can also use evolution to do that and wait. And in gene editing, it may be quicker to do that, right? Because evolution also creates new genetic diversity. Thank you, Fabio. All right. Other remarks? If not, let's go to Jurian's proposition. And the last propositions, you could say, are more in a more general. And Jurian's proposition, I think, has a background in innovation anyway. He said we should not discard a techniques like new plant breeding techniques or gene editing, which is one of those new plant breeding techniques, on perceived risks only, without considering the tremendous potential it holds. So, can you go ahead and explain your proposition, please?
Yeah, I'd like to. So what I notice a lot is that often for GeneSprout as well, we have a lot of discussions with the general public about CRISPR and what they think about it and all those things. And usually we always focus on all the negative aspects of CRISPR, like it will lead to biodiversity loss, patents, monocultures, all the scary things. But I think we are missing the point that it also has so much potential what we can do with it. What I mentioned before, that we can domesticate crops that would normally not be domesticated because it's not profitable for big companies, or we can improve the nutritional quality of our fruits. All those kind of things we can do with CRISPR that would not necessarily be possible with conventional breeding. And I think a lot of these debates that is skipped in favor of all the negative aspects that people perceive.
Okay, well, let's see how our audience feels about it. And there we are. So we should not discard a technique like gene editing without considering the tremendous potential it holds. Okay, thank you all for... Who can I give the floor to ask a question to Jur about it, to Jurian about it? Not in our yeah, Rosanna, go ahead, please.
I was just going to say, what do you think that could be done about this? And do you think it's a communication problem? And do you think you need to go to people and do more outreach and ask what their concerns are and address them? Or yeah.
Yeah, exactly. I think that's exactly what should be done. And that's also why we started GeneSprout, to also communicate with the general public, also to show them benefits of these kind of techniques, but also to inform them of the science behind these techniques, because there's also a lot of misunderstanding and misinformation out there that at least we want to inform the people so that they can make their own decision about it.
Okay, Jurian, I would like to get a bit back in history, and I would like to get back to your proposition and share a thought of mine with you. And it is in the past, people opposing GMOs said we should not accept or use, we should not use GMO plants with only the perceived potentials it holds, you should also consider the tremendous risks. So in your proposition, there is perception and there is some ratio. And I'm afraid I'm a bit worried here that I see the ratio in the potentials and the perceived only in the risks. And I think when you meet somebody who is worried about gene editing, this may feel uncomfortable for this person. Could you respond on that, Jer?
Okay. Can you tell me again what you mean exactly? I don't think I followed it.
Okay, sorry. Maybe it's too complex. So in your proposition, there is perceived risks and tremendous potential. And tremendous potential is ratio, and perceived risks is emotion.
Yeah.
One could also turn it around. One could also say you should not accept a technique based on the perceived potential without discarding the enormous risks.
Yeah.
Is it more clear now?
Yeah, I think so.
And I think people who would feel uncomfortable with gene editing may have the same, more or less the same proposition, but then the emotion in the technique and the ratio, which is not ratio, of course, there is nothing like ratio, but the ratio in the risk. So when you talk with people, I think it could be valuable to realize that. But I would...
Yeah, I think so. The thing is, I think it relates a bit back also to how our European legislation was written when GM techniques became available some 30 years ago. There was a precautionary principle because we didn't know for sure what kind of negative effects genome modification could have. You also, of course, have a lot of movies like the Frankenfoods, where we insert fish genes into our food and all kinds of crazy things happen and they take over the world. Of course, in the last 30 years, now we see that those kind of things have not happened. And I think in that case, there's not really any tremendous risks. But whenever I talk to people, at least, I like to emphasize also that there are not only risks to these techniques, but there's also a lot of potential benefits. And I think we should take both of them into account before we decide immediately like, yeah, we don't do CRISPR because all of these negative things, and completely ignore all the goods that we can do with it.
Okay, more in balance.
Yeah.
Nikita, go ahead, please.
Just talking from how we talk with the public, we also do this communication because I think we as scientists don't do enough to explain what we do in the lab, and also don't do enough to maybe explain it in a way that, because you're saying that maybe the benefits are feelings, but we also work in this in the lab. We try to also find the perceived risks. I mean, CRISPR is being worked on as we speak to make it more efficient, more targeted, to have less risks. But when we talk to people, we also take how they feel very important in this whole debate, because I think it'll come back to my last proposition in the end about the feeling of naturalness. But I think indeed you're right that there can be risks, but we haven't. If you look very factually, there haven't been risks yet in terms of hazards or toxicity or things like that yet. And our hope for genome editing was so much more than conventional GMOs, because finally we could create products which are indistinguishable from products that could be found in nature, which is also now a problem in itself, I see, because you want to distinguish them. But
that's right.
We were trying all this time to produce plants that are similar to nature so that it feels more natural, but now it's also another problem in itself. But yeah, we can come back to that in my proposition.
No, Rosanna, did I see you wave? Or was that? Because indeed, this is the perfect bridge to your proposition, because it's about when we discuss these things, it's not just ratio, and it's perception and it's emotion, and that is fair enough. We, on a random day, we take lots of decisions based on emotion, and it's good, it helps us. Politicians, I'm afraid, they also decide using emotion, not just ratio, and that's good as well, because we ask them sometimes too. And Nikita, your proposition is about one of those things that you can have a long discussion about. It is you see a lot of products in the market, and it's Nivea now has a product. It says 98% natural products and 2% protecting products, and that makes 100%, right? So natural is almost perfect, but we need something extra, and then natural is perfect. And well, that's a perception. What is natural? Nikita, can you explain about your perception? What one considers as natural is often based on personal feelings and not really based upon what is present in nature.
Yeah.
You have to switch on your, yeah. Okay.
Yeah. So the whole point behind this is I really feel that it's very important to understand what people consider as natural, because when we have discussions, it is really, we explain the whole technique, we say that this is how it's done, and in the end, the plant is genetically similar, phenotypically similar to a plant that you could find in nature. So this could have happened in nature as well, but we just do it intentionally. So in the end, your product is actually as natural as any technique can give you, compared to even conventional breeding sometimes and EMS mutations. But it doesn't matter. In the end, it's about how someone feels about that product. Because it says, I once talked to someone and they said, yeah, but crossing pollen seems more natural than using a pipette in the lab. And that is indeed where it stops. That, yeah, you're right, because when you are in a medical field and someone wants to give you a new therapy, then it's okay, because you are familiar with the doctor and you trust the doctor and you have no other option actually. But when it comes to food and when it comes to plant scientists, then I think there needs to be more trust, and there needs to be a bigger bridge between scientists who work in the lab and scientists who interact with people. And I really hope that will change, or not change, but at least help undecided people to make their own perception based on everything, facts and feelings.
Okay, thank you. So let's get to your proposition and see what our audience thinks about it. So go to your mobile again and please vote. I noticed that the last question did not get much response. Say less than half of our audience was responding. That is better. So I think by the way you explained, Nikita, you also explained why you would like to discuss this. It's a very important subject to discuss with each other. And I think it's also a very beautiful subject to discuss with each other, because it helps to understand one another and hear what somebody thinks of what is natural, and maybe even adopt our crops or technologies based upon what feels as natural, because that may feel better. Thank you for our audience for responding. That's lovely. A lot of people responded. Okay, so Armin, is natural a concept that has passed by in our talks with stakeholders, and if so, in what way?
Well, so far, at least with chicory, it didn't occur that much. But I totally agree. From other areas, I know that naturalness is a very important aspect. But it's a very fuzzy concept, and there are different conceptions of naturalness depending on cultural, your beliefs, your experiences, and many more. So, and it's also a bit difficult to, if you point at something that you find in nature and say, okay, it's part of the nature, therefore it's okay, it's good. Then you have to also agree that mycotoxins are good because they can be found in nature. Yeah. So it's a slightly difficult story. The fact that something is natural in the sense that it is found in nature doesn't mean that it is kind of considered beneficial. Yeah. So I think we have a very Western view on the topic. And if you would ask people that are, if you are from the Southern Hemisphere that are struggling with threats from nature and threats from agriculture, then they would think differently, I think.
So it's you could call it a luxury problem, because in the West we are living in luxury.
Yeah, well, kind of, perhaps.
Who would like to respond in our audience, in our roundtable? Yeah, Ramon.
No, I just want to point out that it's indeed a very difficult subject, and also like our brain is like programmed in a way that our negative emotions are much stronger perceived than something positive. So if people hear some bad things about a certain technique, they are way faster and stronger reluctant to like say like, okay, no, this is something bad.
Yeah.
Also, and that's also very important nowadays, if they hear fake news and things that are not true, and those are negatively charged, then also those things stay longer in the brain. And although then you can like completely scientifically prove that these things are not right and they were wrong, people still have this bad feeling in their minds which are connotated to it. And I think that's really hard to get out of it. Or I actually don't know how to influence people in a better way. I don't know if it's clear.
Yeah, inform and influence, I guess. Yeah. Hey, Katja, you're a scientist, right? So one of us who is doing non-natural things is you, right? Because you're totally in the lab. When you talk with people around you and explain about your work, like you did in the introduction, you showed a plant in a pot, which is not really natural, right? You go to the lab, make a piece of the plant and treat cells in order to get the DNA changed and then get a full plant from one cell. That doesn't really feel like natural. It could, at least. How is your surrounding, family, friends? Do they ever mention this to you?
Yeah, sometimes I get questions about that, but I also try to explain about it. And for me, the fascinating thing is that not the plant breeding itself, but the potential of plants to improve our diet and to be even used as a kind of apothecary for many medicines that we need nowadays. You know that we have we do live in an age where we have almost too much food, so we have a lot of lifestyle diseases coming up. And thinking about diet or thinking about new medicines, I think that's when I tell about that, people get very interested and very inspired, and they also start thinking about the medicinal plants that we have that are not used anymore, but they could be a source of antibiotics or medicines that we need. When the food is more than only nutrition, it can be functional, so it can do very good things for your body, for your health. And I think when you explain the purpose or what the driver that is behind your work, people are much more interested to listen about it than when you talk about techniques and the DNA and the proteins, because those are so small. And well, I can see them in my imagination when I work with that, because I can imagine it in how it looks in 3D. But for somebody else, these things are so difficult to grasp, and they are invisible, and they're not a part of everyday images. But if you talk about the purpose of and the story behind it. What drives us when we do the research? I think that's when you get more understanding and you can tell the story also about chicory and why this plant is so interesting much better. But to talk about the techniques, there is a, I wouldn't say lack of understanding. There's just no image with it. We like to think in pictures or in images, and that's very difficult. So in the project, we also asked artists to try to make images for us, to try to make a story for us, that we could tell the story about gene editing and about chicory in a different way. So now we have two groups of artists that are coming to our laboratory and learning about it, and they are inspired by what we are doing, and they are making artworks to tell about our work. And that's
and
much
they're
more
not just inspired by the blue flowers, they are also inspired by your work, right?
Yeah, they're also inspired by the compounds that they see and how what we are doing. They are trying to understand it, but they completely make a different visual, beautiful visualization of what we are doing. And I think that we need to build those bridges to be able to tell the story about what we are doing as scientists.
Okay, there's another hand. Yep.
Just oh yeah, sorry.
Go ahead, Nikita.
Oh,
I also
okay.
had the Q&A open and it was in front of your face. I could see your hand, but I couldn't see your face.
No, that's okay. No, but I really think Katja put up a really nice point, because Julian and I had done quite some of these talks with people of younger generations, but also some of the older generations and middle generations and all of them. And when you really talk about your own research very enthusiastically and really show your passion for why you do it, because a small part or maybe even a big part of a scientist is to finally see their research being applied for the betterment of society. And I think when you explain it that way, people are really open and much more open to changing their perspective, or at least having an open perspective on new things.
Yeah. Okay, I promised Peter van der Meer to get back to his remark, and I think we may all have seen it, that in 2018, July, I think it was, there was a European Court of Justice ruling. And for many of us, it meant that gene-edited plants are supposed to be treated as genetically modified. In other words, when you develop a crop that is has a new trait thanks to gene editing, you should go to the European Union authority to prove that it is safe for food and so safe for the environment, which takes, say, 10 million per variety, which is very costly. And of course, people are discussing this ruling. And Peter van der Meer says that, please remember that the statement that the European Court of Justice ruling categorized the organisms developed through NPBTs as GMO is an assumption. Well, I think it is in practice, it is that way. And that the European Court of Justice ruling itself doesn't say that. Well, I'm not, of course, I'm not a legal expert, but yeah, Armin?
Yeah, just to comment on Peter's statements. I think I guess what he implies to say is that in order to qualify as a GMO according to the EU legal text, the genetic material needs to be altered in a way that it doesn't occur naturally. I think that's the way it's being phrased. And I think his argument is, and his analysis is that actually, if you do, for example, a point mutation by genome editing, exchanging one base pair or a few base pairs, then this is something that can occur naturally. So therefore, this wouldn't qualify to be a GMO then. So I think there is, what he's trying to argue is, I think that there is still not clear that certain types of gene-edited crops would really qualify as a GMO. And this has to be clarified in the coming months.
In the coming months?
Yes, so I think there is the announcement of a European commission study for April next year. In the course of that study, we would expect the clarification also on the legal issues, on the leeway that the definition allows for genome edited crops to be included or excluded.
Okay. Thank you, Armin. So yes, good to talk also about legal things, which is not our specialism, and that's not bad. I think this more or less brings us to the end of this meeting. It's almost 7:30 here in the Netherlands, 6:30 in the UK, in Glasgow, Scotland, not England, sorry. I hope you all enjoyed this program. This roundtable was organized by CHIC, and I would very much like to thank our guests. Hang on. Boop, boop. So today we had 6 guests from outside CHIC, Rosanna, Sonia, and Fiona from the Embra Collective. And this is where you can find them. Do you see the faces in front of the QR? So that's better now.
Erik, I can leave it up at the end of the meeting so everyone can see it for a minute or so, and then they can look it up.
Okay. So you can all visit both GeneSprout and the Embra Collective. Here you got the where you can find them on Twitter, and the QR code automatically brings you to the website. So Nikita, Ramon, and Jurian, also thank you for contributing. Also in the preparations, I think I've learned a lot from the talks and from the preparations. I've enjoyed it very much. That's also nice. And so I think for now, also of course, Armin and Katja also thank you, but you're involved in CHIC, so it's your business, right? It's your work. Thank you all for putting this effort in sharing your thoughts with each other, talking with each other. For me, it was a very nice meeting together, and I thank the audience for giving input. And I saw there was quite some interaction in the chat with the people. We couldn't cover it all, but I saw that there were also interactions between people in the audience. Thank you very much. Is there any last remark, or did I forget something to mention? Not? Well, then I would say take care. I hope you will have a good holidays, preferably with some people, well, loved ones around you, and stay healthy. And hopefully in another time we'll meet again and then even shake hands or give a hug to each other.
Thanks, you guys. Thank you guys for coming and for participating, and for the audience, thank you guys for watching.
Thank you all, and take care. It was very nice meeting all of you.
Yeah, I agree. Thank you.
Thank you. It was nice to meet you all too.
Yeah.
Till next time.
Thank you.
Bye-bye.
Bye-bye.